In this lesson, we're going to talk about basic differentiation and figure out some shortcuts. And so when we look at this, this looks just like our definition. Now, we're kind of used to an H being there, but it's the same thing. All right, it's the limit as 2 points get close together. It's a slope formula, okay? Derivative is a slope. Now, let's talk about some shortcuts. Okay, so if we look at this pattern, if you notice, the 7 is being multiplied to the 10 to make 70. And then the power goes down by 1. Same thing here. 4 times negative 5 is negative 70. Power goes down by 1. Think of 3x to the 1. 1 times 3 is 3. And then the new power on x would be 0. But this is no x's, so we wouldn't write that. So that's why there's no x. All right, think about negative 2 is already like that. And what happens when you do 0 times something? You get 0. So that negative 2 completely goes away. Excuse me. So then we have, see if negatives work. Negative 3 times 12 is negative 36. And then remember, you're subtracting 1 from the power. Okay, so in general, you multiply power to coefficient, and then you subtract 1 from the power. Okay, so constant rule. If we're taking derivative of constant, like how we did negative 2, that gives us 0. In general, the power rule is going to be nx to the n minus 1. The n goes to the front. The power is lessened by 1. Derivative of just x is 1, because if you think about it, this is 1x to the 1. If we use power rule, we could do it. Then we have this nifty little rule saying if we have a number in here, we can actually move it to the front. So it's going to be c times, and then you just do the derivative of the rest. Okay? We had a similar rule for limits. All right, derivative. G prime of t. You're going to go 2 times 4/5. That's 8/5. T, you can write 1 if you want. You don't need to. Slope of the graph at t equals 2. We did this before. G prime of 2. We're just plugging 2 in. Now, what really gets people here is all the numbers and adding and subtracting and all that. It's not the calculus. All right, although if you look at this one looks weird. What we're going to have to do is prep it. So we need to rewrite the square root of t to be t to some power. Square root of t is the same as saying to the 1/2 power. All right, and then t in the denominator is the same as saying negative 1. That's just a refresher on what those exponent rules from Algebra 1 and Algebra 2 were. So then we have y prime. 1/2, excuse me, 1/2 times 2, that's 1. And then t, we didn't have to write the 1, by the way. If I subtract 1 from 1/2, if I get a common denominator, I can see that that's negative 1/2. Go off to the side if you need to. All right, negative 1 times negative 2, that's positive 2. Again, go off to the side if you need to subtract the 1, especially when you're dealing with fractions and negatives. This is totally fine for your answer. Now, if this was multiple choice, probably what they would do is they would rewrite the answer in the format that it was given to you in. And so this would probably be 1 over square root of t plus 2 over t squared. You do not have to do this, but just know that this is how your multiple choice answers would look. Okay, last problem. We need to prep it. Okay, 1/5 x. Now the denominator, the x is in the denominator, so negative power. The power is 2 and 3 is the root, so that becomes the new power. If you're really struggling with this, please come to tutoring. I don't know what else to say about that. That means that we need to help you with your algebra skills. All right, again, 1/5 times negative 2/3. If you need to go over here, there's no shame. It's better that you do this and get it right than to do it incorrectly, okay? Same thing with the negative 2/3. We need to subtract 1. That's the same as subtracting 3/3. That gets you negative 5/3. Okay? It's better that you do the work over here and get the right answer than if you get a wrong answer because you didn't do your subtracting correctly. All right, let's talk about sine. All right, I'm going to graph one cycle of sine. All right. Up here, by the way, is 1, and down here is -1, and this would be about pi, and this would be about 2 pi. Okay, so going back to how we did graphing derivatives before, I see a max, that makes a 0. I see a min, that makes a 0. I see a positive slope, so I'm going to draw a graph above. From here to here, I see a negative slope. That means I'm going to go down, come back up, positive slope. What did I just draw? Cosine. The derivative of sine x is cosine x. Okay, likewise, if I graph cosine, so there's cosine x. Again, we got pi, we got 2 pi. All right, 1 and negative 1. If I want to graph this, then I would start at the maxes and mins. You may think you know what the answer is here, but just bear with me. Negative slope means go down. Positive slope means go above. Sorry, and then come right back to that. This is not just sine. This is actually sine flipped, or negative sine. Be careful with that. You need to just memorize that, and that is all I'm going to say. Okay, I need to prep this before I move on. Okay, so I need to rewrite this sine x over 2 as 1/2 sine x. The next thing is totally fine. The next thing is fine. This is not okay. I need to first of all distribute the negative, and I need to divide by x squared. So I'm going to go through this quickly, so pay attention. Negative 5x, x cubed over x squared would just be x. Okay, plus 7x. X over x squared, that, if I think about 1 minus 2, that's going to give me an exponent of negative 1. All right, and I'm kind of leaving myself much room here. Minus 5x to the negative 2. This right here turns out to be negative 4x, by the way, and I'm going to go ahead and simplify that. All right, so I'm going to leave myself more room for the f prime of x. 1/2 sine x, the derivative of that is going to be 1/2 times the derivative of sine x, which is cosine x. The derivative of cosine x, remember, was negative sine. So minus 7, negative sign, that's going to actually change that to a plus 7. 2 negatives make a plus. Derivative of minus 4x is just minus 4. Keep using power rule. Negative 1 times 7, negative 7. Subtract 1 from the power to get negative 2. Negative 2 times negative 5 is plus 10. And again, subtract 1 from the power and you get negative 3. And we're going to leave our answer just like that. All right, here's a good example of when you need to know both the long way and the short way. Okay, this looks an awful lot like this. Limit as h approaches 0, f of x plus h minus f of x all over h. It looks almost identical. What we need to do here is we need to find f of x, then we're going to find f prime of x, then we're going to go f prime of some number. Sometimes they give you the number and sometimes they don't. See how this is, instead of x plus h, it's 8? They're telling us that the number is 8, but we're not going to get to that till the end. Okay, look after the minus. In fact, let's just put an x on top of the 8. This right here, after the minus, see, minus f of x, minus 3x squared. That's our function. Our derivative then would be 2 times 3 is 6x. And so all I got to do here is plug in 8. And that's how you get the answer. That gets you out of doing a very messy limit problem if you just know some derivative rules. Okay? This is a review right here. I'm going to say you should practice this, pause it, and then I'm going to give you the answer. I'm already doing that, so sorry if you hadn't started yet. All right, that was just some extra practice.